Hi, welcome to Unit 4, Day 6, Ionic Compounds. This is Part 2, where we're going to learn about polyatomics. So just to recap, the aim of this lesson is for us to be able to check the chemical formula of an ionic compound to see if it's correct or not. And if you recall from Part 1, in order for it to be correct, the overall charge must be 0, and the subscripts must be in the lowest whole number ratios possible, also known as the empirical formula. Now we're going to learn a little bit about polyatomics, and you may not know what that means right now, but let's sort of recap some things that we do know and learn a few new terms. So many ionic compounds are made up of just two types of atoms, one type of metal and one type of nonmetal. Examples of that will be something like sodium chloride is just made up of sodium and chlorine atoms. So you have your metal sodium and your nonmetal is chlorine. Calcium fluoride is another example. Again, it's made up of one type of metal, calcium, and one type of nonmetal, fluorine. Aluminum oxide would be another example, again, made up of one type of metal, aluminum, and one type of nonmetal, oxygen. So even though you may have more than one of those atoms, you have, for example, two aluminum and aluminum oxide, there's only one type of metal and only one type of nonmetal. These are called binary compounds, and bi meaning two. You just have two types of atoms. However, you've seen some examples where the ionic compound is made up of more than one type, and it's usually made up of one type of metal and then more than one type of nonmetal. Examples of this would be something like copper sulfate. So if you break this down, you see copper is you have one type of metal, which is copper, and two nonmetals, sulfur and oxygen. Calcium nitrate would be another example. It has a calcium and two nonmetals, nitrogen and oxygen. And then sodium acetate would be another example. In this case, it's made up of one type of metal, sodium, Na, and then three types of nonmetal, carbon, hydrogen, and oxygen. These types of compounds that are made of three or more types of atoms are called ternary compounds. Ternary means three or more than three. All right, let's see if we can recognize a ternary ionic compound. This is a select all that applies. So pause the video now, and when you press play again, the answer will be revealed. Great, the answer to that will be B and C. So these are all made up of three or more types of atoms. You may have chosen D, but the reason why D is incorrect is because it's specifically asking for ternary ionic compounds, and D is not an ionic compound. It's made up of all nonmetals. And in fact, D is known as, colloquially known as vinegar. Okay, so how is this relating to this topic of polyatomics? So ternary ionic compounds, like the ones you've seen before in the previous example, they are made from polyatomic ions. So what is an ion? Remember, an ion is anything with a charge, and it can be a cation, positive charge, or an anion has a negative charge. And a good way to remember cation versus anion, cation, that word has a T in it, which looks like a plus sign, and anion has an N in it, which is the letter that begins the word negative. So that's how you can remember the charges of those. But anyway, ion is anything with a charge, and a polyatomic ion is an ion that is made up of more than one atom, poly meaning many. Most of these polyatomic ions are anions. Most of them are negatively charged. With one exception that you ought to know, it's ammonium, NH4+, which acts as a metal. So ammonium compounds, even though it's made of nitrogen and hydrogen, they're all non-metals, ammonium itself acts as a metal. So when you see it, treat it as a metal. Now, the other thing to know about polyatomics is that you want to keep the ions together. They sort of act as a group. And the charge that you see for the polyatomic is the charge for the whole group. So for example, for ammonium, NH4+, that +1 charge is for the entire thing. So all of ammonium has a +1 charge. That does not mean that the nitrogen has a +1 and the hydrogen has a +1 and the other hydrogen has a +1. It means no, the whole entire thing has a +1 charge. Okay, so let me introduce you to the polyatomics. Here they are. You don't need to memorize them at this moment, but you do need to be able to recognize them in a chemical formula, because that will help you to know when you're needing to use this resource, this polyatomic ion chart. So we're going to look at some examples, and the purpose of that is just to get more familiar with these polyatomic ions. So in these examples, you're asked to identify the name and the charge of the polyatomic ion in the ionic compounds. So if you look at this polyatomic ion table, you will see you have the formula on the left and then its name on the right. So looking at each of these compounds, what you have to do is identify what part is your polyatomic and what part, so you know what part you're focusing on. So for example, in KCN, what part of this is your polyatomic? Once you've identified where your polyatomic, what's your polyatomic, then you want to see if you can find it here in this table. So first you look on the formula to find the formula. Then once you found the formula, you look over to the right to identify the name of the formula, and then the charge of that polyatomic will be on the upper right. So you can pause the video now, and then when you press play again, the answers will be revealed. Okay, so here let's go through these. The first one is KCN, potassium cyanide. So remember polyatomics are mostly nonmetal, so I highlighted it just to make it a little easier. So CN is my non-metal part, so that's what I'm probably going to be focusing on. And I just scroll through and then bam, here it was, CN. The name of that polyatomic is cyanide and its charge is -1. Next one here, Na2SO4. The polyatomic ion, again, is our non-metal part usually, so I'm focusing on that. That'll be the S and the O4. That subscript has to go with the polyatomic, just so you know. So I'm looking for SO4, not SO, but SO4. So I look in the table, and bam, there it is. The name of it is sulfate, and it has a -2 charge. The next example is a little strange, because in this example, you'll notice that there's a parentheses here. And the parentheses will go around a polyatomic if you have more than one. So the cool thing when you have a parentheses for a problem like this, if you just want to identify what your polyatomic is, just look for what's inside the parentheses. That will be your polyatomic. So I'm looking for NO3. And I look in the table, and here it is, NO3. The charge is -1, and it's nitrate. Same thing for this next example. It has a parentheses, so I'm going to focus on what's inside the parentheses. It's PO4. I look for it here in the table. Here it is, PO4. It's phosphate and has a -3 charge. Now, the last example is tricky because most of the polyatomics you're going to focus on the non-metal part. But in the case of ammonium, we just have to recognize and remember that ammonium is a polyatomic that acts as a metal. So that's why it's written first, just like all the metals are written first. And ammonium has a +1 charge. So you can find that in the table here. If you want to see this done out, you can pause. There is a video posted, Unit 4, Day 6, Part 2 Examples video. It's in this folder. But if you're fine and you feel like you got it, you can move on to a CFU where you'll be doing the same thing, identifying the name and the charge of the polyatomic. So pause the video now. When you press play again, the answer will be revealed. All right, so here are the answers. You can go through and sort of check them on your own. And if you need to pause the video, you can do so. Okay, so we saw in the previous example that there were these parentheses, and I mentioned that we use them when we have more than one polyatomic, and we put it around the polyatomic. So let's go over what the parentheses in the chemical formula tells you. We put parentheses around polyatomic if there's more than one polyatomic ion. The subscript, or the small number on the outside of the parentheses, will tell you how many of that polyatomic ion there is. So, for example, if we have something like copper acetate, this is actually copper 2 acetate, what exactly does this molecule look like? So that number on the outside, that subscript there, tells you that it's going to have, you have a single copper, but you have 2 acetates, so 2 CH3CO2s. And so this is what it would sort of look like as a particle diagram. Notice how we have 1, 2 CH3CO2, 2 acetates, and then a copper in the middle. Now, the subscripts on the inside, like the 3 and the 2 on the inside of the parentheses, they belong with the polyatomic, so make sure you keep them together, okay? So remember, the subscript on the outside tells you how many of that polyatomic ion you have. Okay, so now you're going to do these examples. How many polyatomic ions are there in each compound? So let's go through each one together. I'm just going to remove the chart because it just will make it easier for us to explain, so I'm just removing that. But first example, potassium cyanide. I know that there's only one cyanide or CN minus because there's no parentheses. The next one is sulfate. It's only one because there's no parentheses. Here we have calcium nitrate. There are two because there's a parentheses, and the subscript outside the 2 is a 2. So that means there are 2 nitrates or 2 NO3 minus. This compound, it has parentheses as well, and inside the parentheses we have phosphates, and there are 2 of them, and I know that there are 2 because of the subscript outside. So the subscript outside tells me that there's 2. And then for ammonium, I know that there's 1 because there's no parentheses around that polyatomic. All right, so why don't you try it now with CFU8. You can pause the video now, and when you press play again, the answer will be revealed. Okay, so here are the answers. All right, last CFU, it's sort of combining what you did in part 1 and part 2 of this lesson. So here you're asked to check the correct formula of barium nitrate. And remember, in part 1, we learned that the overall charge has to be 0. So I've highlighted where barium is. It's here, has a +2 charge. I highlighted where nitrate is. It's here. It has an NO3, so it has a -1 charge. That's written there. So you're going to use that information to see if this is actually the correct formula. Does the overall charge of the barium and nitrate, as written here, equal 0? When you press play again, the answer will be revealed. Okay, so the answer is this is the correct formula. And remember, the way that we do that is we write the charge of the cation and anion. So barium has a +2 charge, nitrate has a -1 charge. And then remember that we multiply the charge with its subscript. So since nitrate has a subscript, outside the parentheses of 2, we're going to multiply 2 with its -1 charge. Now when we add those charges up together, the +2 from barium, and then the overall -2 charge from nitrate, sorry about that, the overall charge will equal 0. And so we know that the sum of the charges equals 0, so it's correct. All right, that's it for this video. Part 3 is next.